Assalamu alaikum dear students. Today we are going to learn about RC circuits. So RC circuits consist of resistor and a capacitor. So you know that resistor dissipates electrical energy and a capacitor stores energy, that is electrical energy, in E field or electric field, or it stores charge on plates. So we are going to analyze those circuits which contain these both components, resistor and a capacitor. So we are going to find the all variables such as charge, voltage and current across these circuits. So we have a diagram. We connect a battery, source battery, that has EMF E0, and there is a switch. Initially it is open, and a capacitor that is connected in series with resistor. This is R resistor, this is capacitor. So initially there is no current or no voltage because switch is open. As we close the switch, means we provide the path to the current and the charges, and the charge starts flowing across the circuit. At T0 the current is maximum across the circuit. Circuit current is maximum, and because Vc is 0, voltage across the capacitor, Vc is the voltage across capacitor. Initially voltage across the capacitor is 0 because initially the capacitor acts as a wire, normal wire. Initially when time is 0, so current is maximum, voltage across the capacitor is 0. But at later time greater than 0, the voltage across the capacitor Vc start increasing because charges on the capacitor keep building as time increases. So positive charge on this and a negative charge on this, equal charges on both plates. So a voltage is developed across this capacitor. That voltage we call Vc. So as voltage develops across the capacitor, the current start decreasing. So we can also show that relationship mathematically. So we have mathematical expression for that. We know that the EMF of the battery, so we will find that by KVL, Kirchhoff voltage loop rule. So we know that the battery voltage is equal to the voltage dissipated across the capacitor plus voltage dissipated across the resistor. So that is equal to voltage of the battery. So you know that the voltage Q, charge and the voltage have relationship that is given by Q is equal to CV. So as charge increases, voltage also increases. So we can take, this is Vc, so we can write Vc as Q over C. So this is EMF Vc is equal to Q over C, plus we know that V is equal to I into R. So you can put here I into R and divide right and left hand side with R. So RR cancels. So this becomes E naught over R is equal to Q over RC plus I. So here you can see that this is E naught over R. This is maximum current of the battery that battery provides, and this current is at any time across the circuit. So you can also write that IT is EMF over R minus Q over RC. So as charge builds up, current, maximum current start decreasing. So you know that as charge will increase, so will voltage increase. So this term becomes 0 0 0 and a 0. As charge is maximum on the plates, so this whole term becomes 0, means when charge is maximum, charge is maximum, it implies that current will be equal to 0. So whenever charge is maximum on the plates, current will be equal to 0. So now we will derive expression for charge, current and a voltage. So we can write that whole equation again in form of differential equation, that is Q over C plus R dq over dt minus EMF equal to 0. So we wrote this equation, this whole equation in this form. This is a differential equation. So when you solve a differential equation, you can find a general solution, and a general solution for the charge will be, by solving this differential equation, we get this charge at any time across the circuit is equal to maximum charge on the plates 1 minus e power minus t over RC. So this function is exponential function. So charge builds up slowly on the plates. So initially when time is t is 0, if you put here t 0, so you will get q of t is 0 when time is equal to 0. So initially charge on the plates is 0, but at later time as time increases the charge builds up exponentially. So we can also derive expression for the current from this expression, and here RC is a time constant for any circuit. For RC circuits, this is known as capacitive time constant. So it is time that how long a capacitor takes to charge. Okay, if C is greater, as capacitance is greater, then time it also takes longer to charge fully. Okay. So it depends, and if its R value is greater, then it also takes longer time to charge. Okay. So tau depends on R and C. It has dimension of time. Its unit is second. So here we can also derive expression for the current. So how can we derive expression for the current? Only just take the derivative of this equation. So we can take derivation of this equation dt, and this q naught will multiply with this one, because q naught is constant, this is maximum charge on the plates, so it is derivative will be 0. Only here derivative that we will take of this exponential function, that will become q naught minus 1 over RC e power minus t over RC. So this is current at any time across the circuit. This is expression for the current, or we can also write it minus, we know that q is equal to vc or cv, so this we can write as v naught into c, or EMF we can also write here as EMF, because we have taken there as E naught, so here we can write as E naught C over minus 1 over RC e power minus t over RC. So CC cancels, so here it is minus minus cancels, E naught over R e power minus t over RC. So this is E naught. So we have expression for the current. This is expression for the current across RC circuit, and we can also derive expression for the voltage. So to derive expression for the voltage, we can multiply this equation with C. So if you multiply this equation, so this equation will become Q of T. If you multiply with C, then this becomes QC 1 minus e power minus T over RC, and this becomes voltage at any time across the circuit, and this is maximum voltage 1 minus e power minus T over RC. So this is expression for the voltage across circuit. So we can also write the how variables behave when there is zero time across the RC circuit. So let's, when we have time 0, and we will analyze the current, voltage, okay, and a charge. So when time is 0, the current across the circuit is V over R, or we can write it EMF. EMF overall means maximum current, and the voltage across circuit is, across the capacitor is 0, and charge is also 0 initially when time is 0.